Hello everyone. My name is Sugimoto from the Financial Data Science team. In this session, I would like to talk about how data science technology is improving the experience of receiving information from LINE Pay official account. I will first explain the background and the mission of improving the information receiving experience of LINE Pay official account. Then, I will introduce two examples of improvement that were made to achieve the mission. First, quantifying the usefulness of messages from the official account, and second, improving the accuracy of user targeting based on message content. The last part of the presentation will be a summary of the session. Now, background and mission. LINE Pay is a mobile payment and a money transfer service provided by LINE. By registering as a friend of the official LINE Pay account, users can receive various messages within the LINE application, such as updates on new LINE Pay features and campaign information. To date, approximately 48 million people, mainly LINE Pay users, have registered as friend of the LINE Pay official account, making it an important communication channel for delivering information to these users. However, by August 2019, the average number of messages a user received per month was over 30, which is a very large number of messages. In other words, users were receiving a lot of unhelpful messages, since the system was not optimizing who to send messages and what kind of information would be useful for them. In order to solve these problems, we set a mission to deliver useful information to each and every user and made improvement. Here are two examples of improvements we have made using data science techniques to achieve our mission. First, we quantified whether the messages were useful to the users or not. If we could identify messages that were not useful to users, we could review the number and the content of such messages so that users would be more likely to receive useful messages. The usefulness of the messages to users was evaluated using two indicators, the message click rate and the non-block rate of the official LINE Pay account. The message click rate is a percentage of clicks on a link in a message by the user who received the message. The user clicks on the link to learn more about the content. Therefore, the higher the message click rate, the more users are receiving useful information. The non-block rate is a percentage of users who receive messages and do not block the official account. Since users tend to block information that is not useful to them, the higher the non-block rate, the more useful information users are receiving. Using these two indicators, we defined a message that is high, the upper right of the figure, as beneficial to many users, and a message that is low, the lower left of the figure, as not beneficial to many users. The message click rate can be easily calculated since there is a click log for message. The non-block rate can be calculated as 1 minus block rate, so I will replace it with a block rate in the rest of my presentation. In calculating the block rate, the only data available was when and how many messages were blocked, and when the official account delivered the message for unknown reasons. As shown in the figure, the number of blocks increased rapidly during the time when the message was delivered. We considered the possibility of calculating the block rate using a back-and-forth comparison, but we found that the block rate could not be calculated using simple aggregate logic such as a back-and-forth comparison, since 2 to 3 messages are sometimes delivered in a day. To solve this problem, we thought that we could calculate the block rate by applying a statistical model to the time series data of the number of blocks per time period and decomposing it into the number of blocks caused by messages and the number of blocks caused by the other factors. For this purpose, we first analyzed the blocking behavior of users. As a result of the analysis, we found that there is a regularity in the blocking behavior of users. The figure on the left shows that the number of blocks when no messages is delivered is cyclical in terms of the day of the week and the time of the day. The number of blocks at this time of day and day of the week is statistically about the same. The middle figure shows the number of blocks after the message has been delivered. We can see that the number of blocks is highest during the time when the message is delivered, and the curve decreases as times go by. Furthermore, we found that this curve fits the power curve perfectly. The figure on the right shows the cumulative percentage of message clicks. It turns out that about 80% of all clicks occur within about 6 hours of the message delivery. In other words, the action on the message occurred within 6 hours of delivery, suggesting that the block is also likely to have occurred within 6 hours. We came up with a statistical model to formulate the user's behavior towards this block. We assumed that the number of blocks when no message is sent varies relative to the average number of blocks mu with time and day of the week, and that the number of blocks when a message is sent occurs within 6 hours of delivery, and that the number of blocks follow a power curve. Since the number of blocks varies from message to message, the parameter of the power curve is set to a different value for each message. As shown in the figure, both during the time when messages were sent and then during the time when messages were not sent, the actual measured values and the fitted values of the statistical model overlapped, and we were able to create a model that reflected the current situation well. By calculating and visualizing the message click rate and non-block rate for each message, we were able to identify trends in the usefulness of messages. The most useful messages were characterized by special deals and announcement of new LINE Pay features. These messages are considered to be useful for many users, and we found that there is no problem in distributing them to a large number of users. On the other hand, the messages that were not useful were characterized by information about campaigns that were jointly conducted by LINE's financial services and family services and family pay. Since LINE Pay can also be used to pay for financial services, there were joint campaigns, but the messages were found to be unhelpful to users who do not use financial services. We decided to reduce the number of messages sent and improve user targeting so that more useful messages would be delivered to the users. By visualizing the usefulness of messages, we were able to identify the characteristics of messages that should not be sent to a large number of users. In order to ensure that users receive useful messages, we have to reduce the number of unhelpful messages and improve our user targeting. In order to improve user targeting, there is a business goal to increase the number of new users. We needed to improve the accuracy of user targeting for messages aimed at acquiring new users. Therefore, to reduce the number of messages delivered while still acquiring new users. For this purpose, we utilized a method called Lookalike audience targeting, developed by the machine learning team within LINE. With the seed user as the input, we can search for users who are similar to the seed user from all the users who follow the official LINE Pay account using features based on the user's various behaviors on the LINE service called Z features. By setting existing users as the seed users and targeting similar users, we thought we could improve the accuracy of user targeting for messages aimed at acquiring new users. In making the decision to implement lookalike audience targeting, the key question was whether it would be possible to maintain or even exceed the number of new acquisition compared to the existing method, even if the number of messages delivered was reduced. This was the key question. To answer this question, we conducted an A/B test. The following are the result of one of the tests that we conducted for several messages. This is a result of a joint campaign between LINE's crypto asset trading service BitMax and LINE Pay. The existing method of targeting was based on the presumed demographics of the existing BitMax users, male office workers in their 30s. However, this method had the problem that many users who fit the criteria were included, and many users found it unhelpful. Therefore, we compared the accuracy of the number of messages delivered and number of new acquisition for two groups of users. Those with a high degree of similarity to BitMax existing users, and those based on estimated attributes as obtained through lookalike audience targeting. The test results show that the lookalike audience targeting delivered only 1/10 of the number of new acquisition compared to the existing method, but captured half of the number of the new acquisition. At the time, we had a policy of fixing the number of delivery and expanding the number of delivery if the results were good. If the initial delivery of lookalike audience targeting was good, we could further increase the number of similar users to be targeted, thereby reducing the number of messages that were not useful to users and effectively increasing the number of new acquisitions. Based on the result of these tests, the decision was made to implement lookalike audience targeting, and a system was developed to allow planners to run lookalike audience targeting from the CMS that manages message delivery for official accounts. Lookalike audience targeting products already provide an API, and when a list of seed users is uploaded to the CMS can call the API and generate a list of similar users. Seed users can be extracted from the company's Oasis product using SQL and uploaded to the CMS using the API. With this system, planners can send messages to similar users generated by the CMS. Now the summary of this session. In this session, we introduced how we use the data science technologies to improve the message receiving experience of the LINE Pay official account. We used a statistical model to estimate the number of blocks caused by delivery, which is difficult to observe directly. By using this value and the message click rate, we were able to identify trends in unhelpful messages and determine which messages should be targeted more accurately while reducing the number of messages delivered. For new user acquisition, we verified that the lookalike audience targeting could increase the number of new acquisitions while reducing the number of unhelpful messages. Based on the result, lookalike audience targeting was systemized and made easily available to planners. This is the end of my presentation, but I hope it will give you an idea of what the data scientists at the LINE are doing. Thank you very much for your attention.